Okay, my connection was lost. I will continue with the other details. I will just have a revolve tool. I will just summarize this one. I will just create this outline with the details on the side, on the right side. I will just create a detail with this one, with the sketch I have created, as you see in the technical drawing. I have just created a normal center line and give the dimensions which I have seen the profile. I have just created the outline. We have some details on this side and their dimensions as you see here. I will just create this solid by having to create it from the revolved one. I will add some details about our figure. We have a whole feature at this point, which is dimension, which is a little bit different dimension that we are used to. I will just edit this sketch and create a small hole at that point. I will just create a small hole for the center line properties. I will just create a small hole, a little bit smaller than 12 millimeter, let's say 10. I will delete this dimension and give a dimension which I have seen in the technical drawing. But for this, I will use the point on our figure. And I will just give the distance dimension 17.938 millimeters. I will just create a hole with 12 or 10 millimeters in length. I will just create a hole at this point. I will just have a revolve tool, and this time I will use this profile and the profile on the other side and select the axis for revolve tool and make the cut at this point. I will just create a hole according to this face, this cylindrical plane geometry. I will use this point and create a new sketch. Sorry. I can just put a thread here, which is metric 12. With the isometric profile, I have enlarged this threaded field. Next thing, what I'm going to do is I will just create a hole at this point, which is 3 to 3.5 quarter inch with a 16 UND. I will just create a hole feature. This time, a hole on this face, starting on this face, having the sharing the same center here, and I will just create a thread with hole with the length here. As you see, we have a 1 inch, which is 25.5 in length. We have a normal threaded hole starting point, and with the ANSI unified speed, we will just use 3.25, which is 3.125. And we will just add this hole with the full thread, 25.4 millimeter, which is almost 1 inch. I will use the properties with the full depth. I will just create this hole and accept that one as well. We will enlarge actually 3 times 3.5. Yes. Actually, it is 3.1, yes, inside. So we must have a threaded hole. Anyway, We can also just make the line something like this. We can just make a cut with a trim, as you see, which is, we have also an undercut at this point. I will just ignore this detail because I have done this model in the older software properties with Inventor 2018. The dimension here on the undercut is 4 and the other one is 2, and the diameter here we have is 8.2. Let's have this one, if it works or not. If it works or not. I will just go for it. 17.5. Outside, we have some details. That is the undercut distance actually. The trim, I will just make this one. Also this one. This is the undercut distance. The diameter here. Except because it's the same distance which I have dimension. Same distance. And we have a trajectory which is 25.4, which is this dimension. I will just ignore and create a new line with length, and our dimension will be, just I'm going to check, 3 plus 1/4, 4, and times 25.4, which is this one. Yes. So it's 16 inch. Okay. I'll just erase this. First make the undercut. Cut. And this is not an X-ray, revolve. I will just create, use this axis for cut. And use this one, 25. Yes, this one, the length is 25.4. Let's create this one. Yes, it's also which we have covered head. As you see, we have a, I'm going to add a new chart for this one. This is not a metric, unified speed 3.25 with 16 U and with 2V quality, except to add this one. Okay, I will ignore the whole picture and just make this one. Okay. One page. This is the part finished for our figure. I will continue, say my part 5, the part 2, side under body. Side under body. Okay, and close that file. Open the file. Okay, a new file. I'm just going to create the part, feed the piston side. Close and clear the things. I will use the piston units. I will create a new sketch on XY plane, open XY plane visibilities, start a new line, which will be our horizontal line with the center line properties. I will make the midpoint considering this origin line, and I will create a full rectangle having this midpoint of this rectangle will be on this one in order to have a symmetric condition. And full length of our cylinder will be 65, and the diameter of this one is 76.2 millimeters. I'm going to also create a new line, and this line will be a construction line because I will just give some symmetric condition and other things in order to create the mirror operations. For this point, I will just create a new, I will just make join to this one and give the dimensions that I have seen in the drawing. 11 millimeter and 10 millimeter in thickness, and its dimension is, as you see, it is 72 millimeters from the center line, 72. We also have another dimension. I will again create a rectangle here. I will give the symmetric condition around these two lines, and the dimension of this bottom side, we have 65, and we have 6.3, and we have the fillets on these two corners, also this one and this one, and we have this dimension with 1.5. Also the things on these items to be on the other side, and we will just create a new revolve section for our piston with this one. And for rotating axis, we have one axis defined in our part. I would say my part 3 with a piston number. Okay, this is the part. Great. The next thing, I will close, open a new part. It's standard millimetric. The part sleeve stop. I will just start a new sketch on XY plane. I will just follow this outline. We have a two chamfer on each side, which is 1 millimeter. I have ignored at this point. I will just create a new outline, something like this. I will ignore fillets and chamfers at the first side. Please do not make these fillets and chamfers in the figure first of all. I will just create two lines, one horizontal line or with center line properties, and make this line and this point. I will just create another line. This is an empty place. For this, I will just use this one as construction, and I will continue the outline that I have defined previously. I will just start a new outline. You can also make the extrusions one by one. I'm going to make two rectangles. Which one? This is the one here. I will make the trims. I will give the dimensions that I have seen in the technical drawing, 47.6. This is the dimension here. We have, I think I have just made a mistake about this one. I think it is 50, it was 15, and so also 76.2, which is 3 inches. The total length of our figure here is, which is 48.6. I will just create of this one, which is 67.6 inches, millimeters, I'm sorry. I will just create a revolve tool. So here we have a trail for the set speed resting position. For this, I will just create a new solid line. I will just make this sketch visible and edit to just make a point on this one. I will just create from this line and make this line on this point and have a point on this figure. I will just create a new point on this one. Let's try. It works in 2018, but I'm not sure about 2020 figure here. We have a hole, as you see, and we have also a direction. I am just going to make a direction for our hole dimension. Here, I would like to add a normal drill end with the diameter about 4.3 millimeter in depth, and the diameter with a normal hole, and the diameter of this hole is 12.7, and the direction will be about this point here. We have, yes, what I would like to have. Okay, this one I will just enter, create a new hole. This time I will use the y-axis to just make a hole around this direction, and this point, yes, it just grabs this sketch plane here. I'm going to just create a new tangent surface parallel to plane or point. I will just create a tangent surface at this point. Let's create a new point. Anyway, yes, it doesn't work actually. I will just close this visibility again, take it visible, start a new sketch on this face, and get this same point by the project geometry of our figure. We can also make a revolve tool in order not to make this one. Now we have the point here. I will just make a hole here, as you see, with the dimensions I have specified before, as you see. Okay, we have the chamfers on all sides. We have a chamfer on the outside. I will adjust first my chamfer distance with 1 to 1, and also the inside. I have just created this one. Take the usability out and save my part for its sleeve step. Okay. The missing thing that I have is I will go and continue with the next part. This is the bracket part is mostly complex, the most complex part of our figure. Probably will just the other parts are reasonably similar, very easy about creation. We have a cylinder 5 cylinder head. It's a hexagonal part here. We will just create. We have two ways. We can just create a hexagonal part and we will just remove material from it, or we can just create a new part. As you see here, I will just revolve around this one, and the side and the head hexagonal packet part. It depends on your figure, but I mostly prefer the revolve section. Create this part. Part 5, cylinder head. The next thing, we have a center point visible, XY plane visible. start a new sketch on XY plane. I will just create a line for center line with the line center line properties. I will just create an empty rectangle. I'm not going to use the lines here only for construction purposes. This is, I'm not going to, I will do this thing on purpose. I'm not going to use this line. And I will just continue my outline from this point. This is the point which I am just creating. I do this on purpose. I do not give any dimension to this line. Here, what I'm going to do is I will just continue with the lines here. As you see, we have an outline, something like this. Now here we have like this, and it is connected to each other. As you see, we have a distance for 20, which you have seen here. This is the 20. We have a full length, 45.4. I will just enter the distances that I have seen in the technical drawing. This is for 20. The most dimension we have 45.4. The thickness here. We have an inside diameter. The diameter is here 60.8, and it is 3 inch and 3/8 times 25.4 in thicknesses. The outer diameter here is almost 110. We will just create this one. Also, we have a thickness at this point, which is 10 millimeters. We also have a chamfer with a degree around this one. It is 30 degrees, which is this one. And it starts at the degree 90 millimeter here. Also, we have 10 millimeter in thickness, and we have a 60 millimeter in diameter. I'm sorry, I have just got the wrong line. 60, and I will leave as it is. Finish my sketch and get all internal features, extrude to and revolve to. I will have this one. Also select this one, because otherwise I may have something very different. Here I will just create an extrude the other lines. I will just start a new sketch here. I will create a polygon under the rectangle tool and use this line and make this line horizontal like this. And I will take this line into this circle into a diameter which is 95, and I will make this hexagon pocket tangent to it. I will ignore this one, and I will get the geometry, project geometry from this surface. I will cut the other portions which I have left under this one. I will make the cut to outside to the through all sections. I'm sorry, edit. I will change the direction. I'm sorry. I will cut this one. Open the new old sketch. This time, after I have just created this one, I have the revolve tool. Select this face, make this axis around with the cut properties in order to have a shape something like this. And also I will create a new hole with the threaded feature. Here I'm going to use the center point, which I have created with the dimensions that I have seen here. I will use a threaded hole, the normal stuff, because actually I do not use this one. I will use a threaded hole. Here I will just 3 and more than 1.8, which is I think this one, with a true all section with 6 as you see, with a 2A, 2B, depends on your selection. We will use a true all cutout, and I will just create the hole that I have seen here as you see. Okay. I am sorry. This is the 112 MPT. I'm very sorry about this one. This is the home feature. This is 1.5 inch, 1.5 inch with 11.5 MPT contract. Okay, let's make this dimension by giving the dimension first of all. The dimension, I will just define 1.5 25.4. This is the dimension that I'm interested in. I will make the hole here and add the thread for this one with an MPT with a 1. This is a taper thread definition. US standards. Also, I will add a thread here with asymmetric. I'm not interested unified square thread. As you see, it is 3 over 8 with 6 to 8 with the full thread properties. I will add. This is the part finished to now. I will save this part. The last part in this page, is the sleeve lock knot part 6. I will ignore, I'm sorry. I have just created this part. I save, open a new part 6 with sleeve lock knot. Open to visibilities. This time I'm going to use only a normal reroll. Actually, I have it again. Okay, you can save. Start a new sketch on XY plane. Just easy part. And with the dimensions here, I will just create one dimension 72.5 and 76.2. Finish sketch. I would like to keep my symmetric condition here with 90 millimeters. First of all, I have 2 faded chamfers on each side. We will just create with 1 millimeter. Also, I'm going to just create a new hole centered at this point, and this is a threaded hole with 1.25 inch, 3/4 inch, which is this one, as you see, with a 16 with 2B properties, with a true all section, and with a full depth. Right. Here we also have two different holes here. And for these holes, I'm going to just create a sketch in order to get the point here. And the point here is 60 millimeter far from this line arm. And for this, I will just define this dimension for this hole. I will just convert this circle. I need only this point to finish my sketch. I need a hole at this point, which is this one. A normal hole with a blind hole, and the blind hole distance is 12 millimeters, and the hole diameter is 6 millimeters, and the degree on this one is not a flat, and we have a drill end on our part. I will just make a circular pattern. This one, I will take this one to get the second one. This is used for the second one. I will create the two circles here, the two drills, the two holes on our part. This is the part of our on this page. This is also another part. We will just continue modeling, but for this part, I will just stop recording and to get another part with a new video record. I will stop here. I will continue with the part 7 and complete other parts.